All right, so for day 11, we're going to look at infinite geometric series. So for the warm-up, can you identify the following? First term, ratio, number of terms. All right, I'll do that for you. Here's the first term. It's the 75 hanging out here, first term. Our ratio is this 1.2 right here. And that 15 is the number of terms, which is n. Doesn't look like an n. Here we go. Okay. We're going to look at the pi problem today and relate that to this new equation we're going to learn for infinite geometric series. So let's say Grace baked an apple pie and promptly ate half of it as soon as it was done. Wanting to make the pie last, she decides to eat only half of the pie that remains that day. So on day 1, she eats half the pie total. On day 2, she eats half of what is left, so a fourth of the pie, and 1/2 plus 1/4, she will eat 3/4 of the pie. On day 3, she eats half of a fourth, which is 1/8, which means she eats 7/8 of the total pie. You should start to notice a pattern here. On day 4, she eats 1/16, which means she eats 15/16 of the pie. On day 5, she eats 1/32 of the pie. Almost all the pie is gone by this point. She's eaten 31 out of 32 pieces of pie. And day 6, she eats 1/64 of the pie, which means essentially she eats 63 out of 64ths of the pie. So by day 6, not even by day 7, she's eaten most of the pie. If Grace lives forever, will she eat the complete pie? Essentially, she will. There's only crumbs left. All right, so how do we know if a geometric sequence is convergent, which has a limit, adds to a number, or divergent, does not have a limit, does not add to a number? In the zombie problem, the ratio of 3 is greater than 1. Therefore, there are more and more zombies each day. This is an example of a divergent series. So I'll use divergent. Divergent means it will not add to a number. It keeps going forever. Depending on the human population, they will keep turning to zombies. So this should go to infinity because it will keep getting bigger and bigger and bigger if the ratio is greater than 1. So if it's 3 and you keep tripling it every time, it's going to keep growing. In Grace's pie example, the ratio was much smaller. It was 1/2, which is less than 1. Therefore, each term gets smaller and smaller and smaller until eventually there isn't much left of the pie. This is an example of a convergent sequence. Convergent meaning it will add to a limit. In this case, the limit is 1 pie. As more and more pie is eaten, the total amount of pie would reach 1 pie in Grace's problem. So convergent means it will add up to a number. All right, if an arithmetic sequence keeps going to infinity, like tripling every time, its sum will also keep going to infinity. It could be positive or negative, but it will keep going. So mathematically, here's what it looks like. So again, if your ratio, the absolute value of the ratio is greater than 1, it will be divergent. It will not add up to anything. It will keep going. If the geometric sequence is less, or if the ratio is less than 1, it will be convergent. There will be a limit. And if there is a limit, here's the equation. It is the first term, because this goes to 0, over 1 minus the ratio. Okay, so that kind of shows you how we get the equation. And here it is. So the sum is the first term over 1 minus the ratio. How do we use it? Here it is. Okay, so again, if your ratio is less than 1, you can add up all the numbers to infinity. So here's the summation notation. Let's say we want to add up everything. So you'll see that infinity sign, and you can do that when the ratio is less than 1. So here our first term is 36. The ratio, if you take any number, divide by the one before, we get 0.5. Okay, so there is the explicit equation. The sum is the first term, which is 36, over 1 minus the ratio. And you can type it in your calculator, use parentheses, we will get 72. So if you add up all of these terms, all the way down to 0, we get 72 for the sequence. We can do that to change repeating decimals to fractions by first changing 0.444 repeating into a sequence. So here's the first term. The second term, we would have 0.04 because we already have the first 4 there. The third term, we would have 2 zeros and a 4 because we already have 2 4s right there, and so on. Okay, let's plug into the formula. Oh, we need the ratio. So first term we need, here's the first term. The ratio, we would take any term, divide by the one before. So here the ratio is 0.1. So the sum is our first term, which is 0.4, over 1 minus the ratio. All right, so we have 4 over this 0.4. This is like $1 minus 10 cents. That's 90 cents. And if we multiply 0.4 and 0.9 by 10, we get 4 over 9. If you type that into your calculator, you'll get 0.4 repeating. So I'll show you. Oops, that's not my calculator. I did it here. 4 divided by 9, I hit enter, I got 0.4 repeating. Okay, let's change 0.18 repeating to a fraction. Again, here's our first term. Our second term will need 2 zeros and a point, or a 1/8. Our next one will need 4 zeros and a 1/8. Again, because we already have the 1/8 from the previous terms. So here's our first term. To find the ratio, we take any term, divide by the 1 before it, and here it's 0.01. To find the sum, we take our first term over 1 minus the ratio. This is like $1 minus a penny is 99 cents. Multiply both by 100, here's what we get. Reduce the fraction, we can divide each by 9, we get 2 over 11. And if you type that into your calculator, you will get 0.18 repeating. Let's look at 2 word problems, and then you should have enough information to do the assignment. Suhaib drops a basketball from a height of 10 feet. Each time the ball hits the ground, it rebounds to 80% of its original height. Here's the picture. Drops down 10, rebounds to 80%. So if we take 80%, 0.8 times 10, we get 8 feet. So it rebounds to 8 feet. But then it goes down 8 feet. But then it rebounds to 80% of its height. So if we take 0.8 times 8, we get 6.4. But then it goes down 6.4, and so on. So if we write the sigma notation, there's actually 2 sequences. There's the up sequences in red and the down sequences in blue. So I'll do the blue ones first. Let's add up everything. This ratio is less than 1. It's 0.8, so we can do that. So here the first term is 10, and it rebounds to 80% of its height. To that, we will add the red sequence, the up bounces. So again, we can add everything up to infinity because it keeps bouncing. But here the first term is 0.8. So now we will multiply that by the ratio. Okay, so there it is. I'm going to do my work down here because I'm out of room. So here, if we want the sum, we need the first term over 1 minus the ratio. And if we do that, we get 50. To that, we will add our second, again, it's just first term, over 1 minus the ratio, and that is 40. So if we add up 50 plus 40, Suhaib's ball bounces 90 feet total in distance. Now another way to do that is to recognize that these start doubling after the first rebound. So here they double and they keep doubling. So you can take this sum and double it and then add the 10 feet. So here we could take this sum and double it. 40 times 2 is 80. And to that add this initial 10 feet. So that way we get the 90 as well. So 2 ways to do that problem, either separate the sequences or double the second sequence and add the first term. All right, last, what if it doesn't have a rebound? A child on a swing is given a big push. She travels 14 feet total and 3 forces far on each successive back and forth swing. How far does she travel before the swing stops? All right, so here it is. 14 feet over 1 minus our ratio. Ratio is 3/4 or 0.75. Put that in your calculator. It's the same as 14 divided by 0.25, and we can see that she travels 56 feet total.